order to record all possible photographic aspects of the atomic explosion from the ground, the Air Force, supported by the Army, the Navy, and the Marine Corps, built a camera tower and installed and tested various still and movie cameras actually used in the atomic bomb test, complete with all the complex timers and controls necessary for their precise function through the flash and phenomena which follow. The tower housed various types of still and motion picture cameras for which it was necessary to have two sources of power. One 127-volt diesel and one 24-volt Waukesha unit. One of the earlier problems encountered was the vibration by the larger and heavier diesel. This definitely interfered with the operation of the cameras and had to be moved away from the base of the tower. Despite many problems, after months of work both day and night, we were ready to photograph exact test bombs at various speeds in color as well as black and white, with both moving and still cameras. The actual impulse which fired the bomb was timed to arrive at this master relay at 0-1 minute, which in turn passed it on to various precise control units. These units set up a delay relative to the type of camera they were to operate. The K-18 still camera siphon control was a gear and cam device, tailor-made to ensure that the cameras overlapped as they made their 3 still pictures a second. A similar control, also tailor-made for the K-24s, ensured overlapping coverage of 12 still pictures a second, while the high-speed Mitchell movie camera control was coupled to a rheostat, which brought the speed of the film from 0 to 96 frames per second gradually. The -1 minute impulse traveled without going through any control direct to a Maurer 16mm color camera and to the standard Mitchell movie camera. The second impulse at -1 second was received on another master relay for the ultra-high-speed Fastex cameras. There were 11 of these cameras, 9 operating at 12,000 frames per second and 2 at 1,000 frames per second. These 9 high-speed cameras were timed to start at intervals from -0.6 of a second to -0.2 of a second. These delays were set into the control unit with precision test sets. In this type of work, 1/2 second would be considered a relatively long delay. These units also shut off the camera to avoid destruction of the film, as the entire roll passed the lens at the incredibly fast time of approximately 100 feet per second. In order to accurately record and time the film as it traveled at this speed, a pulse generator of 1,000 cycles per second was used to record pips on the edge of all the ultra-high-speed films, thereby furnishing a yardstick to check any given frame as to the time it was exposed in relation to the flash and the phenomena. For practice tests, the fire control was in the tower, and cameras were focused on an M46 magnesium bomb as a target approximately 17,000 feet away. During these practice tests, all problems encountered were successfully overcome. All hoped-for results were achieved, which made possible a slow-motion picture of the actual action of the atom bomb. In this way, we may benefit the world with an understanding of an action, the comprehension of which is too fast for the normal eye.